My name is Hyemin Park at Hanyang University from South Korea. I'll have a presentation about the experimental investigation of polymer adsorption-induced permeability reduction in low permeability reservoirs. Polymer flooding technique, it nearly disappeared in the 90s due to its high costs and the access to new, easy exploitable reserves. But currently, it is again applied solely or in combination with other EOR techniques such as surfactant flooding, mainly in US and China. Polymer flooding is a mature technology in chemical EOR method. It improves the sweep and displacement of oil, bypassed oil from the low permeability zones in the reservoir by increasing the brine viscosity. And we can expect the effect of reduction in water production at production well. The aforementioned effect of the reduction in water production is a result of the polymer retention happens as the entrapment and adsorption happens in the system, and the HPAM polymer injected has the characteristics of water wet. Thus, it decreases the water relative permeability. Thus, the water production is reduced and the oil production increased. In the meantime, the formation of the polymer adsorption layer, it decreases the size of the flow paths for the fluids. So the system permeability is reduced, and we can see the increase in the injection pressure and negative effect in the polymer injectivity. Thus, several researches have been conducted to measure the effect of the polymer adsorption. This Zaitin and Shebato performed one-dimensional core flow experiments. They measured the permeability reduction and then calculated the polymer adsorption layer thickness. But these experiments using the one-dimensional core has some limitations, having uniform fluids velocity and no viscous fingering. In general, polymer adsorption layer is formed in a monomolecular layer onto the rock surface. But this Shevato showed that when polymer solution flows at or higher than the critical shear rate, then the thickness of the polymer adsorption layer can be increased because this polymer molecular can be inserted into the monomolecular layer by this hydrodynamic force. Thus, in this study, we implemented two-dimensional five-spot pattern flow system under the environment of variation in fluid velocity for the locations in the system. Polymer retention during the polymer flooding may enhance the oil flow, but spontaneously it decreases the system permeability. Particularly in low permeability system, the polymer flooding may not show positive EOR effect due to this adsorption. So in this research, we attempted to analyze the effect of the polymer concentration on adsorption-induced permeability reduction in low permeability system. This is a picture of our two-dimensional polymer flooding experiment setup. And this system is set for the reservoir condition, the pressure and the temperature. And the data from the flowing experiments is obtained from through this DAQ system. Our two-dimensional sandstone is inserted into this cylindrical flow vessel horizontally with this upper and lower side of the support to apply the confining pressure uniformly throughout the system. The porous material we used in this experiment is sister gray area sandstone. which has relatively low range of the permeability for the polymer flooding application, which is 35 to 60 millidarcy. And the fluids used for the saturation and the flow were the oil from shell molina, which has 12 centipoise at 40 degrees Celsius, and the brine with 2% salinity, the HPAM from the SNF Corporation, which has 8 million molecular weight. The system is initially and fully saturated with this 2% brine, and then oil was injected to set the residual oil saturation, which was the initial condition for this experiment, 60%. The polymer solution from 0 ppm to 1,500 ppm was injected at the injection rate of 1 per day velocity. The production pressure was set to the 300 psig, and this flow experiment was conducted until oil recovery no more increased, and the data from the flow experiment reached to the equilibrium state. Here is the results of our experiment. If this is the oil recovery according to the polymer concentration, as the polymer concentration increased from 0 to 1,000 ppm, the oil recovery was increased from 17.7% to 60.6%. So we can see that as higher concentration injected, the oil recovery enhanced by this polymer solution. Oil viscosity ratio improved from 0.06 to 0.23. But on the other hand, in case of 1,200 and 1,500 ppm injection, the oil recovery rather decreased to 50% and 31.6%, even though this viscosity ratio more increased to 0.62. We thought this may be attributed to the low permeability of this system, and the polymer retention happened as adsorption and the entrapment during the polymer flooding. So these results would be verified by the following analysis. If you see here, this is the pressure behavior at injection and production ports. The lower line shows the production pressure, which we set to 300 psig, and the upper line is the injection pressure changing by the polymer solution injection. If you see the case of the 1,500 ppm case, the injection pressure abruptly increased to more than 60 psig at the early time of injection, and then maintained for a while. And at 1.8 pvi, it increased again to more than 20 psig, and then maintained. Thus, we depicted the results of mobility reduction to see the polymer retention effect. It indicates the effective permeability reduction. To see the effect of polymer retention happened in the system, which is expressed by the ratio of the pressure differences by the injection of brine and the polymer solution. In case of 500 ppm, it barely changed because polymer retention happened in the system, but it was not so severe, so it was offset by the brine mobility increase as water channeling was formed. And in case of 1,000 and 1,200 ppm case, for the 1.2 pvi injection, polymer retention affected this value, and this number was increased to about 40, and then maintained for the rest of the injection. On the other hand, in case of 1,500 ppm, again, we can see the During the early time of injection, 0.3 PV, it abruptly increased to more than 120, then maintained, and at 1.8 PVI, it again increased to more than 150, then maintained. This, after 1.8 PVI, it increased again because a heavy amount of polymer retention happened in the system and made this additional increase. As you see in the previous results, during the early time of injection, we could see that in case of 1500 ppm, it was higher, more than 5 times higher than the other cases. So we calculated the effective permeability reduction for the early time of injection. So from the measurement, we calculated and listed in the table. If you see here, polymer retention was proportionally affected to the system. So as higher concentration solution injected, effective permeability was reduced more. So far, we investigated the effect of the polymer retention, which includes the entrapment and adsorption during the polymer flooding. And we try to remove the entrapped polymer effect and see the only effect of the polymer adsorption by injection of the sufficient amount of brine into the system. Here, it is assumed that the entrapped polymer solution residue was completely removed from the system. Here's the results. As the brine was injected into the system, we can see that the pressure difference was gradually decreased, and we calculated the permeability reduction when only polymer adsorption affects the system. And also, the thickness of the polymer adsorption and this permeability reduction was yielded from this measurements. Here, in case of 1500 ppm, the adsorption thickness of the polymer was calculated to be 3.34 micrometer, which was blocking 60% of the effective pore radius by this relationship. As I mentioned before, polymer adsorption is affected by the flow velocity inside the porous media. And in case of this two-dimensional system we used, it has the flow velocity differs to the location of the system. So we calculated the maximum shear rate near injection, which has the highest velocity in the system, before and after the adsorption. Polymer solution flowed at 65.48 per second before adsorption, which I mean by the clean sandstone. And as the polymer adsorption happened, it increased to 344, which was higher than this critical shear rate, 300 per sec. This may help that the formation of the polymer adsorption layer to be increased. And if you see here, the brine effective permeability finally decreased from 56 millidarcy to 1.5 millidarcy by 97.3% in reduction. So we can comprehend this oil recovery for the higher concentration of polymer solution injection rather decreased for this significantly huge drop of permeability. In this study, the polymer flooding experiments were conducted and the following conclusions were drawn. In low permeability reservoirs, the oil recovery rather decreased without EOR effect at the polymer concentrations above optimum concentration. The polymer retention in early time of injection was proportional to the concentration of the solution. At high concentration, the effective pore radius was clogged up by 60%. Accordingly, the permeability was decreased from 56 millidarcy to 1.5 millidarcy. Consequently, it was verified that the appropriate injection concentration was important in the application of polymer injection technique to the low permeability reservoirs. Thank you.
Thank you very much. It is the time for questions or comments.
Any questions? No? Unless you have
No questions?
Oh, here we go.
Here we go.
How you regenerate? How you regenerate?
Your polymer.
Polymer?
Yes.
Yeah.
We got the polymer sample from the SNF Corporation, and we just follow the process to make the solution. Yeah.
More questions or
Any more? No?
comments?
Unless you
Okay, thank you very much for. This is your. Thank you very much.